simplify each of the following. And here we have two different exponential expressions. And with these, we're going to be using the rules that we've learned in the past few sets of problems. So let's start with the first one. We've got 3xy squared times negative 2x squared y to the fifth. Now in this case, we don't have any exponents on top of exponents, and we don't have any exponents on top of parentheses, so we don't need to use either of those rules. Effectively, what we need to do here is combine the x's and the y's as well as the coefficients. Everything in this problem is multiplication. There aren't any other operations. There's no addition or subtraction or division. And because multiplication can happen in any order, what we can do is we can focus on the coefficients first, and then the x's and then the y's. So let's start with the coefficients. 3 times negative 2, that's not too difficult. That gives us negative 6. Now let's look at the x's. X times x squared. Well, x is x to the first. And if we have x to the first times x squared, those are two powers of the same base being multiplied, so we add those powers. That was the first rule. 1 plus 2 is 3, so that gives us x cubed, right? X times x squared is x cubed. And then similarly with the y's, we've got y squared times y to the fifth. When we multiply those, we add the exponents, and that gives us y to the seventh. So that first product is negative 6x cubed y to the seventh. The other one's going to be a little bit more involved. We still have 3xy squared, and then we've got negative 2x squared y to the fifth. But in this case, that second factor ends up being cubed. So now we have an exponent on top of a product. This is the third rule. It means that that exponent means distributed to each of the factors in there. So I'm going to leave 3xy squared alone out front. And then I'm going to take this other 3 and distribute it to each of the terms, each of the factors, excuse me. So here, when we take negative 2 and raise it to the third power, that's going to be negative 2 to the third. We'll deal with that a little bit more later. Then x squared to the third power. When we've got an exponent on top of another exponent, that's multiplication. So that gives us x to the sixth. 2 times 3 is 6. And then for the y to the fifth to the third power is also going to be multiplying those exponents, giving us y to the 15th. Good. Let's actually do out this negative 2 cubed. We know that that's negative 2 times negative 2 times negative 2. It's going to give us a negative number, particularly negative 8. And now we can look at the coefficients and then each variable one at a time. If we look at the coefficients, 3 times negative 8 gives us negative 24. So we're going to have that out front. If we look at the x's, x times x to the sixth gives us x to the seventh, because we're adding the exponents, and that first x has an invisible 1 exponent. And then if we look at the y's, we've got y squared times y to the 15th. We add those exponents, and we get y to the 17th. So this one has a final answer of negative 24, x to the 7th, y to the 17th. That cube on top of the second factor really made this a lot bigger. We've got bigger exponents, we've got a coefficient with a larger magnitude. Exponents on top of exponents really make something bigger generally.